Hi everyone, I'm Zijian Zhu. Here I introduce our recent work, Understanding the Robustness of 3D Object Detection with Bird's Eye View Representations in Autonomous Driving. In this work, we evaluate BEV representations' influence on detectors' natural robustness and adversarial robustness. Here is our findings. First, BEV models are more robust under natural conditions and common corruptions. Second, BEV models are more vulnerable to adversarial noises. Third, camera LiDAR fusion models shows better robustness. Then I will introduce you the details of our work. First, let me introduce the 7 models we evaluate. Among these, Focus 3D, BEV depth are camera-only and CNN-only group. DETR 3D and BEV former are camera-only and transformer-included group. Transfusion and BEV fusion are camera LiDAR fusion group. In the first part of our work, we evaluate the natural robustness. First, we test models under common vision corruptions. Following ImageNet C, we found that BEV models are more robust. Second, we test the model's robustness during different weather and lighting. We find that BEV models are also more robust. Thirdly, we test the performance when missing cameras. We find that fusion models are slightly affected. The monocular detector, Focus 3D, has little performance drop, though BEV former outperforms DETR 3D, which indicates that BEV representations contribute to the spatial modeling of overlap regions. In the second part of our work, we test adversarial robustness. First, we test L-infinity perturbation attack. In the left figure, BEV models, which are dashed lines, are lower than non-BEV models, which are solid lines, indicating that BEV models are more vulnerable. In the right figure, as you can see, when image and point cloud are both perturbed, BEV fusion is more vulnerable. So, we wonder why BEV models are vulnerable to adversarial noise. We visualized the BEV feature map and found that adversarial perturbations lead to greater activations in empty areas, and further generate many false positives. Since BEV feature map models the whole 3D space, there are redundant features for adversary to corrupt, leading to worse robustness. Secondly, we test the robustness to 2D patch-wise adversarial attack. In most cases, BEV models are more vulnerable than corresponding non-BEV models. In addition to 2D patch, we also propose a 3D consistent patch attack. We use ground truth 3D bounding box labels to locate the corners of patches in 3D space. Then, we project the 3D corners onto the multi-view 2D image planes. Finally, we use homography to transform the patches onto the images. Here is a demo video of our proposed attack. As you can see, the patches are not only multi-camera universal, but also temporally universal. From the results, we find Focus 3D and Transfusion outperform their BEV counterpairs, but BEV former, which use history feature, outperforms DETR 3D. This indicates that temporal dependency is important for temporal robustness. Finally, we give the suggestions to enhance the detector's robustness. First is to use multi-modal fusion. Second is to use transformer architecture. Third is to use temporal information. That's all. Thank you for listening.